Assalamu alaikum.
Welcome, Salam. I'm here. Oh,
Right. So we completed this portion, right? That
yeah,
is the Pythagorean theorems in 2 dimensions and 3 dimensions, and we were about to start perimeter and areas. Okay, it's been a good amount of effort. Just a second, I have to slow.
that's right.
Okay, so So, what is a perimeter? As we discussed previously as well, perimeters are like the boundaries of any sort of geometric shape. It could be a circle, circle's boundary. It could be a square, square's boundary, and like that, so on, so on. Okay, all right. And we also read about these, like what is the perimeter of a square, what is the perimeter of a rectangle, triangle, trapezium. We completed these, I guess. Okay, all right, and we have gone through these questions as well. Yes, we have gone through this question. There was one question left here. Easy one, but I think we couldn't do it. Okay, no worries. We'll check it out. One from here and one from Pythagorean. I remember that. Okay, so I will check it. No worries. Okay, and now, okay. So we will look at some more of like complex shapes and all, and see how we can find or determine the areas and shapes of them. Okay. Like say for instance, before getting into all the explanations, what do you think if you see this shape? What do you think should be your approach while finding the boundary or the perimeter of it?
Cut it into smaller yet simpler shapes.
Okay.
So,
Actually,
for example,
okay, yes, I know your point, but cut it into smaller shapes like this.
or yeah, but you can also create it, fill in the holes with a bigger shape so it looks simpler.
Yes, you could do that as well. So if you do that, then you will deduct the areas of this portion, right? That is what you tried to say.
Yes.
Okay, all right. So either way we can do it. Okay. Now the question is that is for area, but for perimeter, I mean you don't have to do anything else. Just like measure the
Oh yeah,
sides,
true.
just sides,
Yeah,
measure
measure
the
the sides.
sides,
Yeah.
and add them up. So you will get the perimeter. Okay. And same in case of any shape, actually, you just have to measure the whole boundary, and you will get the perimeter. Okay. Now, to find the areas of composite shapes, split them up into standard shapes, calculate the individual areas of these standard shapes, and sum the answers together. To find the perimeters of composite shapes, it is often easiest to calculate each individual side length and to calculate the total. Okay. Calculate the area of the object shown correct to 2 decimal places. Okay, let's see. So how can we calculate the area of this object? Perimeter is very easy, so I don't think there would be questions from the perimeter. But let's see. First of all, tell me, in first view, in the first place, what are the two shapes that you can see in this picture?
Trapezium and semicircle.
Okay, very good. So this would be our semicircle, and this would be a trapezium. So for the semicircle, we would do is pi r squared divided by 2, which is equals to pi multiplied by 10 squared. 10 is our radius here, okay, divided by 2. Okay, so we've got the one portion. And for the bottom portion, which is a trapezium, what do we get? The area would be,
A plus B times height divided by
yes,
2.
right. So a plus b times height divided by 2. Okay. So 20.620. Okay, so both of them are same. Okay, all right. However, so where were we? So see, what we need to do here is the parallel lines, which are one is 10. Okay, one is 10, and the other one we have to calculate. Okay, so we don't know it yet. So times the height All right, so that is 20. Now the question is, how do we get the value for this one? Tell me. How do we get the value for the other side, which is or the other parallel? I mean, length.
What
How
do you, no.
it would be?
Oh, the radius times 2.
Radius times 2, right? So that would be 20. Okay. So we will get 10 plus 20 times 20. Okay. Did we have to divide by 2? I don't think so, right? Trapezium, in case of trapezium, we don't have to divide by 2, right?
No.
Okay.
Yes.
Okay. So I think so. Okay, let's actually check it. Why am I getting confused? I was actually thinking about dividing by 2, but as you said that you don't have to divide by 2, I think dividing by 2
You
is
have to divide it by 2.
yes, it's a divided. All right, so in this way you can get the answer. Okay, so see, okay, so they have done half into a plus b times h, so 10 plus 20 times 20, and half pi r square. Okay, nice, nice and easy. Okay, annulus. Okay, what is an annulus? Okay, let's say the area between two circles with the same center is known as an annulus. Okay. So this is very easy. So what you have to do is calculate the area of the bigger circle and of the inner smaller circle as well, and I mean subtract the values of these two to get the area of the annulus. Okay, which will be pi times capital R squared minus small r squared. Capital R is the radius of the outer circle and inner circle. Okay, these are very easy things. And what are the sectors? Sectors are fractions of a circle. Because there are 360 degrees in a whole circle, the area of the sector can be found using theta by 360 into pi r square. Okay, fine. So what it means is, say for instance, you have a circle. Okay, you have a circle. Think about a slice of a pizza. Okay, so so you have, say for instance, cut a sector or say cut a slice of it. Okay, so the area of this sector will be known as like a sector. Okay, and how can we get it? Obviously you can understand that its area will also be pi r squared, because as you can see there are terms like radius involved, and also it's a part of the circumference. Okay, but obviously it does not cover the whole circle, it's a portion of it. And how can we get the portion? We can get the portion from the angle at the center. Okay, so say for instance, in case of circle, what is the angle at the center? Tell me.
Angle of the center, 360 degrees.
Is 160 degrees. Okay, so say for instance, in this case the angle is say 80 degrees. Okay, so the area would be 80 upon 360 times area of the circle. Okay, so that would be our area of the sector. And tell me, what would be the circumference of the sector from your idea? What do you think?
Yes.
If I draw it more precisely, what I'm wanting is, what would be the length of this drawn red portion? Okay.
For a second, I thought about radians, but that's not true.
No.
Total.
Think about it. I know that you might not know, but I'm just trying to understand if you understand.
Okay. 2 pi r times the angle over 360 degrees.
Yes, excellent, exactly. Okay, so this would be our circumference, the whole portion, and we are taking a certain part of it. And what is the part there that can be calculated by taking a measurement or ratio of it with 360 degrees? So that would be theta upon 360 times 2 pi r. Very easy. Okay, nothing difficult here. Okay, all right. So let's say, okay, calculate the area of the annulus shown in the diagram. Correct one decimal place. Tell me, what should we do here?
The area of the outer circumference and area of minus the area of the smaller circumference.
Okay, there are no areas of circumference. There are areas for circle. Okay, circumference.
Yeah, area of the circle of the large circle
I
and then area
understand.
of the small circle. Yeah.
All right, so application. Okay, calculations for perimeter and area have many and varied applications, including building and construction, painting, and okay, everything. Okay. So calculate the total area of the sails on a yacht, correct to two decimal places. If the apex of one sail is 4.3 meter above its base length of 2. And the apex of the other sail is from. Okay. Okay, so if we see the image correctly, okay. So I think what you have to do here is, first of all, if the apex of one cell is 4.3 meter above its base length, okay, its base length, okay, of 2.8 meters, and the apex of the other cell is 4.6 meter above its base length of 1.4 meters. Okay, fine. Okay, if we could have been, okay, yes, the drawing would help us more. Okay, that is what I was wanting. Okay, all right. So what they're trying to say is, see, this is one particular consider a triangle actually, okay, and this is another particular triangle. Consider a boat. You are in a boat, sailing in a boat. All right. Now, for the total base length or base length of one yacht sails, that is 2.8 meter. Okay, so one would be 2.8 meters. Okay, and in another case, that is 1.4 meters. Is 1.4 meters. All right, so we've got that. Now, that being said, now what does apex mean? Apex means any sort of, in case of apex, that is the toppest point, right? That is the highest point. Okay, so the highest point,
Yes.
that is 4.3 meters above the base length. Obviously, we would consider a perpendicular distance. Okay, although it's not said, but we would consider a perpendicular distance. Okay, this is 2.8 meters. This is 1.4, and in the second case, 4.6 meters. Now, what do we have to calculate? Total area of the sails on a yacht. Okay, all right. The total area. So that would be half times 4.3 times 2.8 in one case. And in another case, half times 4.6 times 1.4, if I'm not wrong. Okay, let's see. I think that should be the way. Yes, okay. So half times 2.8 times 4.3 and half times 1.4 times 4.6. Okay, all right. So it's better if they give like pictures like this, because I mean, see, it's not expected for a student to understand that you are going to consider a sail as a triangle, because it does not form any triangular shape, right? So that is what
Really?
I was concerned about.
Damn.
Does it form a triangular shape? It doesn't, right?
Most of the time it does.
But it's sort of a curvature, like it forms a curvature based on the air pressure and all, right? Understand what you're
Mm,
trying to say? But
but
see,
like
like,
ever since you were a
isn't
kid,
it like
you
this,
drew a boat with a triangle outside.
like, isn't it like sort of like this shape? Shouldn't it be this shape? Okay, whatever. Whenever you are getting a question regarding sales, you will consider triangle then. Okay, so calculate the area of the object shown. Very easy. I mean, you can easily calculate it. You can divide it into like parts of a trapezium and easily calculate the area. Okay. And one thing that is not said here, but the height is 4 centimeters for all the segments. Okay, as you can understand from the picture. Am I correct? Yes, I think I'm correct. Okay. So the
Yes,
height
sir.
is 4 centimeter for this trapezium at the very bottom, and for other trapeziums and triangles as well. So for this trapezium, the height is 4 centimeter for this trapezium as well, and for this triangle as well. So height is 4 centimeter in all three cases. Calculate the perimeter and area of the object shown. Very easy. Consider this arrowhead to be a triangle and the latter one as a rectangle. Okay, I'm not doing this. Okay. Okay, the circle of radius 8 centimeter is cut out from a square of side length 20 centimeter. How much of the area of the square remains? Round your answer to two decimal place. Okay. So circle of radius is okay. Okay, first of all, let us calculate the area of the square, that is 20 squared. Okay, and the area of the circle will be pi times 8 squared. Okay, pi times 8 squared. Okay, so that will be our answer because it is cut out of the circle. So that means the remainder of the portion is left. So that is why we have subtracted the area of the circle. Okay, is it understandable or is it difficult? Okay, I mean, let me.
Yes, that's understandable.
So see, this is a circle. Okay, I'm sorry, this is a square, and say this is a circle. Okay, its radius is 8 centimeters. Okay, and we have cut it out of this place. Okay, so we will be left with this, and here you will see a sort of thing like it's a void space. Okay, so we won't calculate the area of that. All right. Now calculate the perimeter of the shaded area inside. What is the shaded area? Okay, so blue area is the shaded area. Okay, inside the larger rectangle shown in the diagram, correct to 2 decimal places. Okay, fine. Tell me, would you be able to do this one? There's just one twist. What is the twist?
Which question?
This one.
4. Okay.
Is the perimeter of the shaded region.
Yeah. Oh, okay, sorry. You split the two shapes into a rectangle and a semicircle.
Yes.
The
So for the
one,
rectangle, the perimeter is fairly easier, right? As like 1.5 plus 1 plus 1.5 plus 1. That is our perimeter. But what would be it for
yes,
the semicircle?
2 times 0.5 times pi divided by 2.
Yes. Okay. Good. So if you understand that, then that is good. Okay. All right. And if the shaded area inside the rectangle is removed, what area remains? Okay. Now they are. I mean, there's a very important thing to understand. I don't know if that is what the question is trying to say. Shaded area inside the rectangle is removed. Okay, not the diagram that is removed. Okay, not the whole
Mm.
diagram that is removed. It's the shaded area inside the rectangle. Okay, that is what is removed. So, oh, sorry, what am I saying? Fine. All right. What they're trying to say is, see, there are two rectangles. That is why I got confused. The outer rectangle's area would be 2 times 8, 4. Okay, that is equals to 8. All right. Now, for the inner shaded region, we have is a rectangle that is 1 times 1.5. Okay, and plus the semicircle. So, what is the area for the semicircle? It is pi times 0.5 squared divided by 2. Okay, so then you will just subtract this value from 8. Okay, you will get the answer. Understand?
Which would be 6.11.
Okay, 6.1. Very good. Okay. Okay, so one question. So would you get like one exam on mathematics or like one exam on general mathematics and another one on higher or selective or what is it? Elective mathematics.
Okay, so with the 3 mathematics, specialist mathematics, I'm getting a exam, while the general and methods, I'm getting an assignment.
All right. All right. So I
So
mean,
yeah, with the methods one, I'm trying to find the coordinates of B pretty much. It's really easy. I've already done all the mathematics, but I don't think I can find B and talk about it for 2,000 words. It's just it's a bit weird.
okay, okay, no worries. Okay, so why I asked that? Because in our curriculum, we also take exams on like general mathematics and elective mathematics, and there is also a chance or provision that you could actually skip elective mathematics as well. Okay, if you don't wish to read that. Okay, but most of our students try to take elective mathematics. Okay, because if you like skip elective mathematics, the mm, subjects that are provided in our curriculum are like agricultural studies. So they don't seem to find interest in those. All right. Now next up, calculate the shaded area in the diagram. All right. So okay, so yes, that is the information all in all given. So that is 54 centimeters from the center. Okay. So what would you do? Tell me.
I would for 5A, I would pretty much find the yes. I'm
Okay.
kidding. I'm kidding. I'm kidding.
Okay.
Okay. Times find the full diameter of that diamond.
Okay. So that would be 128, right? That
Yes,
would
and
be
I would use Pythagoras to find the other two sides because it is isosceles, and I would give me the length.
um okay. So you are saying that you would use Pythagorean theorem to find the other two sides. But I
Oh
have
wait, no, I've got an idea.
another option. So my option is
128 times 54 divided by 2 for one side.
100 and sorry again. Can you tell me again? 128 times.
120 54
Mhm.
divided by 2 for one side.
Okay, so one side of the triangle, right? I mean, one triangle, that is the upper triangle.
Yes.
Okay, so you are considering a triangle. Yes, you could do that. Okay. Okay, and I was willing to do another thing, that is consider this as a square. Okay, so I mean, you don't have to consider it's actually a square. Okay, so in case of squares, the diagonals are of same size. Okay, you know that, right?
Yes.
So that is also 128. Actually, you will need to use this property to solve this math as well. So now, as you can understand, uh, the outer square or the bigger square's area would be equal to 128 times 128, right? That
Yes.
would be our bigger square's area. Okay. Now, what would be the area for the inner square? Here you can use the Pythagorean theorem. So now it's a like equilateral right angle triangle, right? Or is it isosceles? I get confused with the term. Anyways, like there are two sides which are equal. Okay, so you have to calculate this side. That would be, say, c squared would be equal to root over 54 squared plus 54 squared. Okay, so you will get a value, and that will be the area of the square. Okay, area of the square, because you can do another thing. Okay, sorry, it's not c squared, it's c, and then area of square equals to box squared. Okay, or c squared, whatever. Okay, so then what will you do? You will just subtract the value of this smaller square from the bigger square. Okay, we will get the value of the shaded diagram. Okay, so these are not like difficult things, these are just like brainstorming things. And as you said that you will be given assignments, so these sort of exercises could help you with that. But isn't mathematics like better if there is a time bound scenario? Because otherwise everyone would score 100 out of 100 in mathematics if assignments are given, because
What's
there
that?
are 1000 and thousands of materials in the internet. You, if you search it, you will get everything, right?
Yeah, that's true, but still.
So I don't know. I mean, if a student, to be honest, if a student is considerate and if he's skilled and talented, no matter whichever curriculum's part he or she is bound to flourish. Okay, he or she is bound to flourish. But what I'm trying to say is, in case of, say, for instance, the ones who are like reluctant to study, that all the students don't want to study, right? Or like there are students who will study if they find proper light, and they might get deviated if they don't find the proper environment. Okay, so in those scenarios it gets important to find the proper system. Okay, otherwise the ones who are talented or who are like keen to study, they will study in any place you like leave them, even if they are in a a jungle. If they find anything to like get educated, they would try to get educated. Okay, so however, so now calculate the unshaded area inside the square shown in the diagram, giving your answer correct to two decimal places. So of the outer square, it will be 10 times 10, and then you will add the area of four circles. Okay, so what would be the area of four circles? Pi times 0.82 squared plus pi times 3.13 squared plus pi times 1.4 squared plus pi times 1.18 squared. You will add four of them and then subtract it from 10 times 10. Okay, understand?
Yes.
Calculate the shaded area shown in the diagram to two decimal places. Okay, so you will get pi times 1.2 squared minus pi times 0.3 squared. Okay, all right. Calculate the area and perimeter of the shaded region shown in the diagram to two decimal places. Okay. So calculate the area and perimeter of the shaded region. Shaded. Okay. All right. So tell me which formula you have to use. We have just read it.
2 pi r times 75 over 360.
Right. Exactly. Okay. And for the area, it would be pi r square
Pi r squared
times
yeah.
75 divided by 360. Okay. Sorry about that. Okay. Now calculate the area and perimeter of the shaded region shown in the. Okay. So now there is a twist. Tell me what is the twist here?
It's the inverted.
Yes, it's sort of inverted. Yes. Okay, so you could do one thing. One thing is that you could calculate it like 96 upon 360 times pi r square. But in that case, what you have to do is subtract it from pi r square. Okay. And another thing you could do is you could do 96 would be, I mean, 360 minus 96 upon 360 times pi r square. Either way, you will get the same answer. Okay, because both of them are same thing. Let's consider these two 360 upon 360 pi r squared. So in the next line, you will get, if you take pi r square in common, pi r square by 360 in common rather, you will get 360 minus 96. Understand what I said? Like I did some algebra here. Okay. Calculate the area and perimeter of the shaded region shown in the diagram to two decimal places. Okay. Actually, let's test you. Okay. Let's see what you do here. Okay. I'm giving you 5 minutes to solve this. It's a very interesting.
No.
It's a
Okay.
very interesting math. Very interesting math.
Okay.
You'll be able to do that. Trying to figure out what the figure is trying to interpret. Okay, so then it should be very easy.
That'll be 1,400. Sorry, 14,661.73 centimeters squared.
All right. Okay. I don't have the way to verify the answer, but I will show you how to. Oh my God. Okay. How to go on with it. Okay. So see, the angle here is 85 degree, which is given. So what you have to do is, first of all, calculate the area of this portion. Okay. So how do we calculate the area of this portion? That would be 85 upon 360 times obviously pi r squared. And what will be the pi r squared? It will be pi times 45 squared. Okay. So we have gotten the area of the portion. And then what we do is calculate the area of this little portion. Okay, so that would be 85 upon 360 times 22 squared. Okay, and just like subtract these values, so you will get the answer. Not 22 squared, actually pi times 22 squared. So that is what you did, right?
Yes.
Okay, so then no problems. Calculate the perimeter and area of the these are like so big exercises. I mean, it takes one day to solve each of the exercise. Like previously the exercises were like so short. Okay, no worries, but these are like very important maths. Okay, calculate the perimeter and area of the shaded region in the half annulus formed by two semicircles shown in the diagram. Give your answers correct to the nearest whole number. Okay, all right. So should we do it? I mean, this is very easy. Okay, so in the like similar manner, what you will do is uh, for the perimeters, you will do 2 pi r by 2, and in case of like areas, pi r square divided by 2. Okay, and the values are given to you. Okay, so you should be able to do this. All right.
Okay. Okay.
The area of
Yes.
the inner circle in the diagram shown is 1 upon 9, that of the annulus formed by two outer circles. So which are the two outer circles? This one and this one. Okay, fine. Calculate the area of the inner circle to two decimal places given that units are in centimeters. Okay, fine. Okay, so now for the outer extreme outer circle, the area would be pi times 6 squared. Okay, and for the intermediary circle, it would be pi times 3 squared. Okay, so you will get a value for this, and if you divide this value by 9, you will get the value of the little circle. Okay, so that is the
Okay.
question. All right. In the diagram, the smaller circle has a diameter of 5 centimeter, and the others have diameters that are progressively 2 centimeter longer than the one immediately before. Fine. Calculate the area that is shaded green to 2 decimal places. Okay, if they were willing to like get the answer for the green, why do they give the orange one? There is no use of the orange one. Whatever. Okay, so
Hmm.
five is the smallest, then 7 would be the red and 9 would be the green. Okay, so the area would be pi into 9 upon 2 squared. Okay, so that would be our answer because the diameter is given, that is why we have divided by 2. Okay,
Okay.
calculate the area of glass in a table that consists of 3 glass circles. The largest circle has a diameter of 68 centimeter. The diameters of the other two circles are 6 centimeter and 10 centimeter less than the diameter of the large circle. Give okay. Oh, I mean, there is nothing to do here. So in one instance, you will use 68 centimeter, and in another instance, 62, and in another instance, it will be 58 centimeters. So these would be the three diameters that you will use to get the answer. Okay. The part of the floor of an ancient Roman building was tiled in a pattern in which four identical triangles form a square with their bases. Very good. Okay. If the triangles have a base length of 12 centimeters, okay, the triangles, okay, so that means the sides of the squares also have length of 12 centimeter and height is 18 centimeter. Calculate the perimeter and area they enclose correct to 2 decimal places. Okay, very easy. Actually, in this case, the area is more easier. Okay, so this would be these red ones would be what 12 centimeters. Okay, 12 centimeters. So 12 squared would be the area of the square. And there are four triangles, so let us multiply by 4 plus 4 first, and then the heights are given as 18, right? Heights are 18, so that would be 4 times half times base times height. Okay, that would be triangles, 4 triangles, so then add them up to get the area. Okay, and in case of perimeter, what should you do?
Add up all the sides.
Sorry.
Add up all the sides. I'm kidding. Find the hypotenuse and then just add up all the sides from that.
All right. Okay. So finding the hypotenuse would be like find this like half triangle or the triangle with half of the base, which is 6.
Yeah.
Okay. This would be
And
18.
18.
Okay? 18 squared plus 6 squared. Square root of it will give you the hypotenuse.
And then times that by 8, and you're good.
Yes. Times that by 8. Exactly. All right. Let me give you another link. Okay.
Okay. I'm just gonna go to the bathroom.
Okay. All right.
Okay.
No worries.
All right. I'll look.